Okay, welcome back. This is part 2 of the ad hoc analysis of a bridge network. In part 1, we used equivalent resistances and voltage dividers to find that the voltage between the two terminals that we labeled V0 is minus 0.13 volts. In this section, or in this video, we'll finish up the problem by figuring out what this current I is. Now, I was so excited about finding the equivalent resistances that I forgot to draw I on the subsequent circuits. But you'll notice that it's the same, it's drawn in the same place each time. It's the current coming out of the source. Well, do we have enough information to find I? It turns out that indeed we do, because we know in the bottom circuit that we have just 100 ohms in series with 3.62 ohms. We've got 5 volts across that combination, so finding I is just a simple matter of dividing the voltage by the sum of the resistances. So I'll clean up some mess from the previous video to get some space to work. And basically then we can say that I will be this 5 volts divided by my 100 ohms plus my 362 ohms. Okay, so I can work this out with my handy calculator. And I get then that I will be 0.0108 amps, and because I'm an electrical engineer, I like to write this as 10.8 milliamps. Okay, so there you have it. We've computed I using this third circuit, and because I is the same in all 3 circuits, that is, in our combination of equivalent resistances, or our computing of equivalent resistances, I never disappeared into one of those equivalents. The I here in the third circuit is the same as the I in the first circuit. So that basically tells us then what the current is. You might want to ask, well, why would I care what the current is? Well, if you're going to have a sensor where you are, for example, you've got a strain gauge, again represented by this 400 ohm resistor, and you might be powering the whole thing with a battery. So you might have a 5 volt battery, and you'll know then that the current is going to be close to about 10 milliamps. That tells you how much energy, well, that tells you how much power your circuit will use, and power times time is energy. You can actually determine the amount of energy that a battery can supply. So that will tell you how long your battery will last with this particular circuit. So just as a side, some of you may think, well, why would I care? That's why you care. So that concludes the videos on the ad hoc analysis of a bridge circuit.